Here is another question from one of our viewers. They wanted to know if they could use a rectangular shape for the floor plan winder design instead of the square shape that is most commonly used. And I really don't see why you wouldn't be allowed to use them. However, you would need to check with your local building department to verify that information, because some building codes require the smallest part of the step to be 6 inches. And I'll show you an example of that later on in the video. And for those of you who don't know what this stairway would look like, with 4-foot wide steps on the bottom and 5-foot wide steps on the upper stairs. And we're going to do the same with these two over here. So let's go ahead and provide you with a view of what this one over here would look like. And then let's go ahead and move over to here. Remember, this is the floor plan layout. The example on the right side of the video should provide you with a little better idea. Now, the reason why I don't think the building department is going to have a problem with this is because the walk lines should be the same if we draw them as circles. And they should be the same if we connect the dots here with a straight line. But it's all going to depend upon how your building department is going to view what a walk line actually looks like for a winder type stair design. And if you notice over here, we got kind of a wild area where you might not have a walk line dimension over here for this section or this section here, because we would need a larger circle to go from this point here to about this point here, and we're not going to have that in our stair design. And this area here could basically be viewed in the same way as if we did something like this. For example, if a person was to walk from this part of the stairway to this part of the stairway and use this as their walk line, then we're going to have 3 different measurements. So if I was to remove the circles, we're going to have kind of an out of whack walk line that you could use to represent this section over here. If I was going to walk over to here and then cut up over to here, or walk over here to here and then walk up the rest of the way, I'm not going to be following a walk line with equal measurements. And in some cases won't even meet the minimum tread depth for the building codes, which is going to be anywhere between 9 and 11 inches. And a few more walk line patterns that might be a little ridiculous, but could be helped to win your argument if you want to build a rectangular shaped winder stairway. And I don't know if this will help, but let's go ahead and take a look at what it would look like with a winder that's going to have equal dimensions on all 4 sides instead of this one here. Now, last on the list, let's go ahead and take a look at what the minimum of 6 inches might look like on your winder stairs with a rectangular shaped floor plan layout. And you would need to check with your local building department to see if you need to use this method or if you could bring it tight to the corner to where all 4 of the front steps will line up at a pivot point like I showed you in the previous examples. And there's a very good chance I didn't answer your question. This is something you're going to need to check with your local building department to verify, and I would definitely get your plan approved in writing, get it stamped, because the last thing you want to do is get a verbal approval and not have something written down with a signature on it. Do not make this mistake. And again, my main concern with the building codes will be the problem area that I mentioned earlier in the video. And for those of you interested in a little more help with winder stair layout, check out this next video. In this video, I will be providing you with a few different methods you can use to figure out a 30-degree angle for your winder stairway. In other words, a winder stairway, one section of the winders that is going to have 3 steps with a 90-degree angle at the center point where the lines are going to come off of these lines here, this line here at 30 degrees. And if you notice these measurements here, the measurement from this part to this part and from this part to this part are exactly the same, along with the measurements from this point to this point and from this point to this point. So if you have a 4-foot square, you can simply use these measurements instead of the last method I'm going to provide you with. After we take a look at our square that is going to have 3-foot measurements on each side. And again, you can take a look at the measurements here that are exactly the same. And last on our list, we will use a 2-foot square with these measurements here. And the reason why I'm providing you with a 2-foot square, even though this isn't going to work for most stairways, is that we can usually insert our 2-foot square into another square that has larger measurements, like this one right here. So here we have a smaller square inside of a larger square, where we can lay out this point here and this point here in this square, and then simply extend these lines out to the point where we need them to be. Or we can use our 3-foot square with our 3-foot measurements also, and simply grab a straight edge like a level and then line it up with our line here so that we can continue this line to the desired point. And we can always check the measurements to make sure that they are the same after we have extended the lines, to make sure that they are exactly the same or close enough for your tolerance. So to provide a brief summary of what we've done so far, we've just simply grabbed a smaller square where we know what the measurements are and extended a line from the center point to our new location to provide us with a 30-degree angle. Next up, let's just go ahead and provide you with a couple of things that you might think would work. And one of those would be to measure across at a diagonal and divide everything up equally. And you can see here where this measurement and this measurement are exactly the same. However, the one in the center is not, for those of you thinking that it might be when it isn't. However, we can use another method that I found while doing some research for this video. And that would be to use a 2-foot radius and simply draw a curved line. And then from this point here, we're going to draw another 2-foot curved line using this line right here as our center point. So not too difficult. And for those of you who need more information on how you can draw a curved line, I do have another video on that. And I will put a link in the video description area to that video. So now that we have this right here, let's go ahead and draw another circle with a 2-foot radius. Now you don't need to go all the way around. Same thing with this. You just need to get to the intersecting points, which would be here, here, and here. Because next up, all we need to do is connect the dots here. If we can draw a straight line from this point right here through this intersecting point where the circles are intersecting with each other, and that would look something like this. Now, once we have this line, we can simply measure the distance from here to here and transfer it over to here. To play connect the dots again and draw a line through here, providing us with 3 30-degree angles. We have a 90-degree angle. If we divide that by 3, we're going to get 3 30-degree angles. And in my opinion, it can't get much simpler than this. So if you enjoyed the video or you learned something from it, make sure you let us know by hitting the thumbs up button. And thanks for watching. To learn more about home building and repairs, visit us at our website. Also, don't forget to subscribe for more awesome content. See you next time.